In this video, we'll be studying about electric cell and electromotive force EMF. Okay. First, talking about electric cell. Electric cell is basically you can define as a device which converts chemical energy into electrical energy. That is electric cell. Okay, and the combination of electric cell, okay, they form a battery. Okay, means combination of electric cell forms battery. Only this much amount of knowledge you need to require here. Okay, you will be studying about more in detail about electric cell. Okay, your electrolyte and other factors will also come, right? The next term is that electromotive force. Okay, electromotive force, that is EMF, right? This is in this chapter we'll be denoting it by E, and there will be a EMF of a battery. Okay, now you can define electromotive force EMF as work done by the cell in forcing a unit positive charge to flow in the whole circuit, including the cell, right? I'm writing this: work done by the cell in forcing a positive charge to flow in the whole circuit. Okay, work done by the cell forcing unit positive charge to flow in whole circuit. Okay, including your cell. Okay, and this is called electromotive force, okay, of a cell. Suppose if dW is the work done in forcing the charge dq, then dW is work done in forcing the charge dq. Then your electromotive force, it will be defined as E is equals to dW by dq, right? And in a steady state, E will be W upon Q. Okay. There are some. Okay, you can also write its unit as well. Okay, unit will be joule per coulomb, or you can say volt, right? You can write dimension form. Okay. See, there are some circuit symbols which we will be using in this chapter. Please note down these. This is a ideal cell. Ideal cell means its internal resistance will be 0. Okay. This is a cell. Okay, having some internal resistance. Okay, these were the uh, symbols that we'll be using. Okay. Now the next term that comes is factors affecting your EMF. Okay. Factors affecting EMF, electromotive force. Basically, EMF is a characteristic of cell which depends on two factors. First one is nature of electrolyte used. Okay, nature of electrolyte used. Okay, and the second one is nature of metal electrode. Okay. nature of metal electrode that is being used. Okay, it will be somewhat like this. Two electrodes are there, filled in electrolyte. Okay, they will be of some metals. Okay, so EMF depends on this electrolyte and nature of this electrode. Okay, one more thing that is important to note here is that your EMF does not depends on area of plate, this area of these electrode. Okay, separation between electrode plates. Okay, and the quantity of electrolyte and size of cell. These are the four factors on which EMF doesn't depend. Okay, so there may be a question that can be formed from framed from uh, this type. Okay, from this knowledge. Now the next thing is internal resistance of a cell. Okay, basically resistance offered by the electrolyte of cell when electric current flows through it is known as its internal resistance. See, when current flows, there will be some resistance which is being offered by this electrolyte. Okay, this resistance is basically known as your internal resistance of a. Okay, now one more thing, let me write it. Resistance offered by electrolytes. Okay, when current flows. Okay, now factors affecting your internal resistance, right? What will be the factors affecting internal resistance? The first factor is that your internal resistance R is directly proportional to separation between plates. D is your separation between the plates. Okay. The second factor is that your internal resistance is inversely proportional to area of the plates. Okay. See, these plates are connected somewhat like this. Okay. These are, they are somewhat like this. Okay. Facing plates. Okay. This distance is your D and this is your area. The positive terminal, this is the negative. Okay. One more thing, one more factor that concentration increases. This implies your internal resistance will also increase. Okay. And the fourth factor is on increasing temperature, your internal resistance is going to decrease. Okay. Why so? Because there will be a decrease in viscosity of the electrolyte that is being used in electric cell. Okay. So these are the factors which will be affecting your internal resistance of a cell. Okay. I hope you have understood this. From the next video, we'll be studying about the terminal potential difference and charging of it. Thank you.